Hi, welcome. So I'm going to try to record videos on different sorting techniques. Essentially, we would go into merge sort, quick sort, insertion sort, and bucket sort. In all these sorting techniques, I would initially show you like a visualization like this on how the essential algorithm works if we try to visualize it, and I would then write like a code in the back, and we'll go over the code real quick, and hopefully you'll be able to grasp at least a little bit more. If you're struggling, well, let me just get into what sorting does essentially first. Like if we have like an array or any data structure, and if we pass in through an algorithm, a sorting algorithm, like this is well written right now, like this, right? If you're like a main function, if you're an array, and we pass it through the sort function that we can design, and there are different algorithms to sort this array, yes. And based on that, like we can sort and return that array. So that's the essential part of it. And one thing to realize is that all these sorting techniques are like in-place sorting, not something like you do in external memory or something like that. Yeah, bucket sort might need it, but not in depth. We can start with insertion sort. What is this sort? Can I rename it? Anyway, we can just ignore it for now. Um, so this is like one visualization example of insertion sort. What this in a way represents an array, and the value of a number represents the height of the graph. So at position 1, 36 is there, and that's why it's that tall. But at 0, it's 2, and that's why it's a lot shorter. Now, the way insertion sort works is that we actually run two loops. The first loop starts from 1 and go this way, right? The And when the first loop is running, inside it, a second loop runs, and it starts with an element before it, so 0. Like if you were to start at 2, the other loop inside it would start from 1 and 0, like 1 and go towards 0, and it would end at 0. What the inside loop does is that every iteration, it would try to find like the smallest element. Like okay, so if we start a loop from 1, it would try to find like the smallest element between 0 and 1, and if we find something, we would like switch it. Then when we go to 2, it would try to find the smallest element between 2, 1, and 0, and it would place it in its appropriate place, and we can just run this visualization and see how it works. Okay, let me just pause this and make it a little slow so you can understand how it works. This thing is not going to show you like how the loops work or whatnot, but just show you like one example. So as you can see, when we went to like 2, 16 was see 16 was smaller, so it took it out and it switched it. It didn't switch it with 2 because 2 was already sorted, and then we go to 15, then it switches it again, then it switches again with 16 and it puts it in the right place. Then we take 20 and then we put it in the right place. That's how it works. And it's sorted. So let's just write the code real quick. Let me copy this. This is just the main function that calls for sort. I'm gonna write here insertion sort, insertion sort, and I'm gonna make a function def insertion sort, and so we'll take it in an array, and it would return the same array. Okay. Now, so with insertion sort, what we do is first we run a for loop. So for I in range, one, and it goes to, remember, it starts from 1 or 0, because we would be comparing with the first element in the loop, inside loop. Okay, so it goes to range of length of array, runs the loop. Okay, what the hell is this? And what we do is I would make another variable j, which would start from a position before I, and I would make another loop for j in range. Start with I. No, my bad. J. Why am I doing? You can just, my bad. -1. Say till 0. You know what I'm gonna do? I'm gonna actually do a while loop because I need to compare too. So that's j b I -1. While j is greater than or equal to 0, and element at j plus 1 is less than element at j. Now that's how you run the loop. Why is the thing screaming? Okay. Now, what we're gonna do is, if this thing happens, like let's say element at 1 is smaller than element at j, I'm gonna make a temporary variable, and we're gonna store the value of j. Now, if j would have value element j plus 1, the smaller value comes in. Now j plus 1 is gonna have the bigger value, 10. That's how you switch it. Now, essential thing is we're reducing the value of j as well. Right. Let's try to run it. Oh yeah, that's silly. Line of an array. Don't need to run range. And you can see the array is sorted. Now, the time complexity of this one would be the worst case scenario would be O of n square because like let's say if there is an element like if 2 was way over here, right? And or 1, I guess 1 was way over here, and to find the 1 over there and to put it back over that, it would take us would in a way like make us do two loops. So we would go to the end and we would have to come to the way to the back. So in the worst case scenario, it's O of n square. But if the array is already kindly sorted, it's not O of n square, but the worst case scenario is O of n square. So that was insertion sort. This is honestly a fairly bit simple. We can look at the bucket sort. Bucket sort is actually a weird, I guess, way to sort things because the underlying idea of bucket sort is that we in a way know must or we in a way must know um, what values are actually gonna be um, in our array. So what I'm trying to say is that if we know that our array has just like selected specific selected numbers reappearing multiple times, we like this like 0, 1, and 2. What we can do is essentially like create like buckets or like let's say we can create like um let's write this to help you explain. Def bucket sort, and we're taking the array and it has to return the array. So just remember this in place sorting, so we'd be returning the same thing again. Okay. So what we essentially do is we make an count like or we make a bucket, and that bucket would have like since we know the elements would be 0, 1, and 2, um we can make a bucket with 3 zeros, and this 0 would actually represent the index of this bucket. So like if I have like 2 zeros in this array, I would run a loop and I would put like at 0th position 2. So and the ones are also 2, and twos are 3. There are 3 twos. So from looking at this bucket, like after I run that loop, I can tell like, oh, in the loop, there are like 2 zeros. 1, 2. There are 2 1s because it's position 1, right? And there are 3 2s because it's position 2. And I can run another loop that actually goes through every position. When it's at 0, it adds the first two element as 0. When it's at 1, it adds the next two element as 1, and so and so. But the only condition in this scenario is that we know the numbers, what kind of numbers they are, and they are like in the same kind of numbers that are repeated. Well, let's just run the loop first. I'm gonna make this 0. Okay, so we are gonna run a for loop on for element in array. We are gonna run. So what we're gonna do is in the bucket at position of element, Hmm. I'm incrementing. So at position 0, it would be +1 because bucket at, if it were 0, it would represent, if they were 1, it would come out as 1 and would have 2. So that's how increment the counter. Um, so after that loop, that bucket would be full. Now we're gonna run the loop through the for I in range of length of, I don't know if this is the right approach or whatnot, but so what we can do is, okay, so we are at I and we need to run another loop for G in range of length of bucket at I. So bucket at I becomes this number. If you were 2, we would run the loop 2 times. So all we would do is, in our original array, at output counter is 0 and at position counter, I would put in I. So it start with I as 0, then I would go to another loop and bucket dot I would be 2 because there are 2 zeros, and 0 goes in, counter 1, and I'll increase the counter, counter plus equal. If you're asking me what this counter is, it's a very valid question. So the counter is a counter variable that is pointing to elements in array. Just show you. So the counter is actually pointing to this elements because this thing is untouched. We just have a bucket. So what we're doing is we are doing in place substitution of values because our bucket's gonna look like two, two, three. You're gonna do in place substitution. That means that for the first position, we are putting it I, which is 0 here, right? It's 0, and we are at 0, and we're putting it twice. So counter is position 0. So this 0 becomes 0. Increment the counter. Again, we go in. Let's see if it works. Something felt wrong though. Hmm. Let's look at the code ourselves, right? Like what's up? Like there is a bucket. This is literally same. The object of type int is no length. No clue. This could be very silly, but like, damn. ChatGPT. I'm gonna ask you what the problem is. Hide this. This was this. It is almost correct. Logical error in the nested loop. Oh, I mean, yeah, because bucket.I is already a number, so we don't need to count the length of it. Oh my god, silly mistakes. Takes forever sometimes. Yeah, it's already now. Anyway, let's just save this shit. Anyway, let's just go to quick sort. Is another fancy way of sorting. You're gonna copy this thing in this one. Um, what quick sort essentially does is it finds so let's quick sort. What this essentially does is it in this array it finds pivot element, any pivot element at the center, I guess. And what it would do is it would make two different arrays. One with all the elements smaller than it, another with all the elements bigger than it, right? And we are randomly selecting a pivot element from the middle. And what we essentially do is we recursively do the pivoting thing, and we return all these groups of array together. Let me show you. Is there a visualization of quick sort? Let's just look at it. You'd find a pivot, show depth. Perhaps this is not the best way. quick sort visualizer. Hmm. It found a pivot. 34 of the pivot. And everything on the left of it is supposed to be smaller. 34 is not the pivot. 105 is the pivot. Damn, I don't know. Like, I would say go to YouTube and Abdul Bari, quick sort. This, look at this video. He explained how the visualization worked. This one too. So what I would do is I'll write the code. Hopefully you grasp something. Okay. So I make a definition of quick sort. I'm passing the array and returning the array eventually. Now, what we would do is every time we are calling quick sort, right? The base case is that if length of that specific array is less than or equals to 1, it becomes 1, we will return the element itself, right? Why should it be less than 1? It's a very good question. Because sometimes it does, you go in depth. Because we'll talk about that later. For now, let's just focus here. Okay. We find the pivot element based on this formula. What we do is length of array mid, the length of array, and we divide it by 2. Now that's this floor divide. So if it's like an float, it would just give it an integer, proper integer. Pivot is the element that is array position mid. Right? Now here's the thing. Left equals to x for x in array if x is less than pivot. All right. X for in array if x is greater than pivot. We can return quick sort Um, okay. No, left plus pivot in array plus quick sort. I know this is very flawed. I didn't do it. It did work. It actually worked. Who would have thought I did it? Let's see if there were like two elements, like two twos. So it just prints 1, 2. Hmm. Yeah, because we need to find mid, which is gonna have x, x, and array, x plus 2. I did it. That worked like a charm. Let's look at the code. See, they didn't do that. That's the flaw in their code. Not mine. Mine works fine. If they're multiple element, it does work. Anyway, last one is gonna be much more challenging. Merge sort. Merge sort incorporates this idea of dividing an array into several blocks, and then we try to merge it. The essential idea lies in merging two sorted arrays. How do you merge two sorted arrays? First, I would actually recommend you watching Abdul Bari. He has a really good explanation on how the merge sort actually works. This example, two-way merge sort iterative method, it goes into depth. First, I want you to look at that video because that's one resource that really cleared things up for me. Now I'm gonna write this code in Python, and hopefully if you have watched that video or if you have some idea, you'll be able to grasp things with much more detail. So first, instead of going right into the code, I'll just tell you how to merge two sorted arrays. So we will do some magic here, but after that, we'll go into that later. But after that, let's say we have two arrays, left and right. These two arrays are actually sorted, and our goal is to update original array, which actually has elements of so what has happened is that we have an array, right? We divide that array into two separate arrays, left and right. and they are both sorted. Okay, now our goal is to merge those two sorted arrays. Okay, so what we would do is we would take three different variables. I points to the left one, j points to the right one, and k points to the original array. So we run the loop. As long as I and j, which are both individually pointing to these two arrays, are less than their length, both, okay, we run that loop. So this loop will stop when either of these element has reached the last element in their array. So if one reaches the last, it just stops. Okay. So with every iteration, what we would do is compare the element of left and right, and whichever one is smaller, we put that element in K, or actually in the original array, and and then we increment the value, right? Now this iteration stops when I would say one of them has reached the end. Like I reached the maximum, but the J still has few elements left. So for that, we would run two additional loops because we don't know which one of these has reached the point. So we would take every element from I if the I are left and put it in K. If K or if I has not reached the limit, that meant J might have reached the limit. And if I had reached the rate, and if we needed to add elements from the right sub array, we would do that. And what it does here is like it takes every element of right and every element that was left and put that was left but is of right, and we put that every element in the array, the original array. And that's how the merging works. Now let's look at the actual sorting algorithm, how it works. So the merge is the core concept of it. That was possibly more difficult part of the code. So the thing about merge sort is whenever we call the merge sort, we need to pass in the start and the end. We are gonna do that recursively, right? So when we're like performing like sorting of an array, we don't know what the start and end will be because essentially at some point we're gonna recursively call the same algorithm again inside. So you can see here, it's inside merge sort, right? So what we would do is we would make like a sort function, and inside that we would call to merge, and we would put the start as 0 and length of the array as an end, and we would return the original sorted array again. So when we call merge sort, it takes the array, it takes the start at the end, and the base case is that end has to be greater than start. If it's less than or equal to start, it just returns nothing. That's the very base case for this one. Let's remember that. Okay. Now, we find the mid from the start and the end, and we divide those two arrays. And we perform like we divide the original array into two. One begins from start to mid, and the other begins from mid plus one to end, right? We divided those arrays and we perform the merge sort on it. Now at the end, we would have we would merge those two arrays, this one and this one. So we would pass in that array, start, mid, and end, and based on start, mid, and end element, we would form the left and right based on those things. And we perform the merging operation as we had talked earlier. So when it does the merge sort here with that mid element in the array, if we do this, we are making left as a new array with the elements of this and array, elements of array that starts with start and ends with mid plus one. We are essentially doing the same thing, but we are just in a way representing it. So yeah, that's what is to merge sort, but merge sort could be a bit tricky. We are doing it for the first time. Abdul Baris was the one that helped me. Let me show you. Yeah, showed up. Yes. See, I broke it into two. Now it's merging it recursively. So after one recursion or one iteration, you would have one sorted array. And then for this one, it would have another sorted array, and then we merge it. But it's doing the same thing again inside it. Those are sorted. Now we're rearranging it, putting it back. These two are sorted. So we're gonna merge them. Yeah, now we're gonna merge them. You put it back. Now we're gonna merge two sorted arrays. Yeah. Yes, there are lots of content on YouTube as well, where people are actually trying to show you how it works. But that was my way of explaining things. I hope it helped.